Hello, this is Mr. Holly. We're going to be looking at lesson 16 today, which has to do with applying properties of operations to multiply and divide rational numbers. So we're really looking at properties of multiplication and division here today. So as we go through each of these properties, we're going to stop, we're going to look at the property, and then we're going to find different ways to apply it that are going to make our lives a lot easier whenever we try to multiply and divide. So for instance, let's go ahead and get started here. On the first one, we see that we are multiplying 5 different factors together, and we are using the commutative and associative properties of multiplication. So let's just go ahead and remind ourselves what those are. Commutative is the idea that A times B is the same as B times A. The order does not matter. I can move those numbers around. The associative is the idea that A times B times C, if I put B and C in parentheses, is the same as A times B times C. This just means commutative up here means that I can move the numbers in any order, and associative means that I can multiply them any two together that I choose to multiply together. They can associate in any way, just like you could pick your friends to eat lunch with. You could associate with whomever you'd like at lunch. Well, in multiplication, the numbers can be associated with whomever they'd like. So we can move them around, and then we can multiply whatever numbers together that we'd like to first. So let's look at this example. Now the first thing I would pay close attention to is the number of positive and negative numbers. So really the number of positive numbers is insignificant, but the number of negatives. I have a negative, a negative, a negative, and a negative. And I would like to think about that. If I have 4 negatives, think about multiplying negative numbers, right? So a negative times a negative would be a positive. And then if I multiply that by a negative, I would get a negative. And then if I multiply by a 4th negative, I would get a positive. And the easy way to think about that is if I have an odd number of negatives, my product is negative. If I have an even number of negatives, my product is positive. So here, 4 negatives, that's going to be positive. I know that I'm going to have a positive product. Okay. Now the thought is, how would I like to multiply these numbers together? You could just do 6 times 2 is 12, times 2 is 24. Now I got to do 24 times 5. Let's go down here, let's do that. Then I'm going to get some product, and then I got to multiply that by 3. It'll be a lot of multiplication. You probably have to work some of that out, do some on your calculator. But if we thought about this in the easiest way possible, we could probably just say that I know 2 times 5, that's going to be 10. And I know negative 6 times 2 is going to be 12. So let's go, or really negative 12, and this is going to be 10 this times negative 3. I would rather multiply everything together besides this 10 and do that at the end, I think. So I'm going to move them around. Negative 12 times negative 3 times 10. 12 times 3 is 36. They're both negative, so that becomes positive. Times 10, and that's 360. And that multiplication became really easy because I just multiplied them in an order that was convenient. What types of strategies did we use? Well, we used the commutative property. We used the associative property. And we could even say that we used our understanding of place value to know that if we multiply by 10, everything just increases by place value. So here this was associative. Then we had commutative because we moved the numbers. Then we chose to multiply the first 2 together using associative again. So we used our strategies here in order to make that a relatively easy multiplication problem. Can you identify the benefits? Well, we just did. We could even just leave that blank. We identified them. What is the sign of the product? How was the sign determined? We also did that. Because we had an even number of negatives, that made it positive. So I'm going to say positive because There's an even number of negatives. You could say negative factors if we wanted to be a little more specific. Okay, next page. We are continuing to use associative and commutative properties on these three exercises. Okay, when I see these, I see a 10. So I know that, multiplying by 10 is easy. So before I start making larger numbers, I might save this 10 for the end. I see three negative numbers, so I know my product is going to be negative. Let's go ahead and start to rearrange those. I'm going to do a negative 1 times negative 3 is 3 times 10 times, so I'm really just associating these together. Negative 2 times 2 is negative 4. And now I'm going to change the order because I think it would be easiest to multiply 3 times negative 4 first and then multiply by 10. So this was associative. This was commutative. Now I've got negative 12 times 10. That becomes very simple multiplication. All right, next. All right, now we get into everybody's favorite thing, which is fractions. Honestly, I'm going to show you a strategy that's going to make this very, very easy for you. And what it is I want to find numbers that are compatible. So anytime I see a big product like this, I think about this like each of these integers are some fraction over 1. And what I want to do is try to simplify. I want to try to create a fraction that I can simplify. And I'll show you what I mean by that. So if this is negative 1/2, so if I have 1/2 here, what kind of number would need to be in the numerator for me to be able to come out with a whole number? An even number. Like if I had 2 or 4 or 6 or 8 in the numerator of this fraction, it would divide out and become a whole number. So as I'm looking at these, I want to try to create fractions that are going to divide out into whole numbers, into integers. So I'm going to look for the ones that might play nicely together. So here, I'll keep the 4 over here, and I'm actually going to look at these two together. 1/3. Do we have any number that is divisible by 3 that I could use here to create a whole number? I see one, 9. So 1/3 times 9. Now I have these two numbers together. Negative 8 times negative 1/2. Again, we're looking for a number that is divisible by 2. 8 is divisible by 2. So the way I would think about this, and I'm just going to kind of write it out for you so you can see it, is now I can think about this as either 1/3 times 9 is going to be 9/3, so 9 divided by 3, or you could think about it as 1/3 times 9 over 1, and I can look at these and say, oh, this numerator and this denominator are going to cancel. If I divide this by 3, I get 1, and if I divide this by 3, I get 3. I can simplify that fraction. Do the same thing on this side. Actually, I'll do this side showing you the other way of thinking about this. Negative 8 times negative 1/2. Oh, well, that's 8 halves, because 8 over 1 times 1 over 2 is going to be 8 over 2. And that's going to become 4 times 3 times 4. Don't lose sight of the fact that we had two negatives here, so that becomes positive. And now I can multiply this however we'd like. Do we want to go 12 times 4, which is 48? Do we want to change the order, go 16 times 3? Either way, we're looking at 48. All right, what terms did you combine first and why? I found for the first terms that I actually the first terms that I used were the fractions, and I wanted to find factors that could easily be divided by the denominator. Factors easily divided by the denominator. And maybe I should be more specific, not just easily, but easily divided by the denominator to create whole numbers. Right, we were able to take fractions out of this problem completely by multiplying 9 times 1/3 and it becoming 3. Like, we were able to just completely get rid of the fractions. All right. We've already talked about sign. We're going to skip that question right there on exercise 4. Now, exercise 2. Actually, let's stop right here, and we will do 2 videos.